Hello everyone, today we are going to solve Leetcode problem number 144, that is binary tree pre-order traversal. So in this problem we are given the root of a binary tree and we need to return the pre-order traversal of this tree. So let's get started. So the question says, given the root of a binary tree and we need to return the pre-order traversal of its node value. Right. So let's move towards the intuition. First of all, we need to understand what is pre-order traversal. So in pre-order traversal, we follow this order, that is root, then left, then right. That means we're going to visit the current node, that is the root node. Then we're going to move towards the left subtree, and finally we're going to move towards the right subtree. Suppose we have this binary tree, right? So basically this is what the root node and this is what the left subtree of this root node, and here we get the right node of this root node, right? So according to this order, what we can do is, I'm going to take a pencil. Okay, so first of all, according to this rule, first we need to consider the root node, which is 1, right? So we're gonna take this 1, right? Then we need to move towards the left side of this root. This is what the left side, right? Then we need to move towards the left subtree, we can say, of this root. So this is the left node and this is what the right node, right? So we have already considered the root node, then we need to move towards the left node, which is 2, right? So I'm going to write over here 2. Now it is connected to 2. Okay, now let's consider this subtree. So according to this subtree, this will going to act like a root node, right? And here we get the left child of this node and here we get the right child of the node, right? So this is the root node, so we need to move towards the left side. Again we're going to follow the same order for this subtree, right? So we need to move towards the left side, which is 4, right? So I'm going to write over here 4. Okay, now again we're going to check for this subtree. So we have already done with the node, root node, then we have already done with the left side of this root node, and then what we need to do, we need to move towards the right child of this root node, right? So here we come to know that we need to go with this 5 node, right? So if you're gonna see we have already considered all the node which is situated at the left side of this root node, right? So according to this order, we have already done the root node, which is 1. Then we have already moved or already traversed all the left node. Okay, like this is what comes under the left subtree, right? Then we need to move towards the right subtree, which is this, right? So at the end we're gonna connect this with 3. So this is how we need to do this, right? I'm gonna repeat this again, that what we are doing, first we visit the root node. This is the root node, right, which is 1, right? Then we move to left subtree. This is what the left subtree and this is what the left child according to this root node, right? If this is a root node, so this is the left child and this is the right child. Okay, so we are going to consider this 2, right? Then again move towards the left side, which is this, right? So here we get the 4. Now 4 has no child, right? 4 has no child, we have null, no left child, no right child, right? So we will be go back, right? Then we're going to visit the right child of this 2, which is going to be 5. Then we'll again go back over here, this main root, and finally we move right sub tree of this one, which is going to be 3, right? So the pre-order traversal will going to become like this, right? So basically, in order to solve this problem, we're going to use recursion. So why do we use recursion? This is the question, right? Because tree themselves are recursive structure, right? Because every subtree, you're gonna see every subtree is also a tree, right? This is a subtree, this is a subtree. Here also we get the node, here we also get the left child, here we also get the right child. That is why every subtree is also a tree, right? So that is why we're going to use a recursion, so that it become easy and cleanest approach. I think it is going to be the easy and cleanest approach to use a recursion, right? And don't miss the end of this video, because I'm going to explain the dry run of the recursion, that how recursion work in this problem. Okay, now let's move towards the coding part. Okay, so as we know, we need to return the list, right? We need to return list. So first of all, I'm going to make a list of result list. I'm going to name them result equals to this, because the return type is list, right? Okay, as we know, because we are going to use a recursion, right? So we need a helper function for that, right? Then only we're going to call that function again and again. So I'm going to make one function for that, that is def. I'm going to name them pre-order, so that it become easy. Yeah. And then I'm going to pass the root node. Suppose just I'm going to name them node, right? But basically we're going to pass the root node. Okay. Okay, now one more edge case is there, that if node is null. Now look at over here. If I'm going to consider further of this fourth node, so we don't have any other node, right? The left child of this fourth node is null, and the right child of this fourth node is null, right? So there is no need to move further. So this is what the edge case. So if not node, if not node, or we can say if node is null, right? So at the time we'll just simply return that. Return means we're going to go back, right? So if not node, so at that time we'll simply return, right? Okay, now what we need to do, as we know, in pre-order traversal, first we're going to append the node, that is the root node, right? So that is why I'm going to append the value of root node, right? So result dot append node dot val, right? This is going to be the root node. Then we need to move towards the left side of the tree, right? We're going to consider the left subtree. Okay, after that, so for that we're going to do the recursion. Okay, so for that we're going to call this function again. So I'm going to call them preorder, preorder, and there I'm going to pass the left side of this node, which is going to be node dot left, isn't it? Then we're going to move to, and after that we're going to consider the right side of the node. So for that again I'm going to do the recursion, that is preorder node dot right, and we're going to, at the end we also need to call this function. So for that I'm going to pass preorder. There I'm going to pass this root, which is already given in the question, and at the end we need to return the result, isn't it? So return result, right? Okay, now let's run this. Accepted. So before submitting this code, I want to show you how recursion work in this problem. I wanted to do the dry run for this. Okay, now let's see the dry run of this code. Okay, let's start the dry run of this code. So basically we are just taking a simple tree, right? So first of all, we need to pass the root node, which is this. Okay, so one is the root node. So I'm going to take a pencil. Okay, so first of all, in this function, we're going to pass a root node, which is 1, right? So instead of this node, I'm going to pass a 1. Then we're going to check that whether this node is null or not. So no, it is not a null node, right? So we're going to append this inside our result. We're going to append this node inside our result, right? So result dot append node dot with. So we're going to append this node inside our result, which is going to be like this. So one is appended inside our result, right? And then again we just call this function again, right? Preorder node dot left. So we are just calling this function again, isn't it? And this time we are passing preorder, we are passing node dot left. So what is the left node of this root node, which is 1? That is 2, right? So we are passing 2 over here. Means this time I'm passing, instead of node, we are just passing 2. Right? Then again we are checking that if node is null. So no, this node is not null, right? So we are just appending this node inside our result, which is going to be 2. Right? Then again we are calling a function. Again we are calling this function, means we are just calling this function again. So I'm going to mark it over here, and this time we are passing node dot left. What is the left node of this second node? What is the left node? Which is 4. So this time we are passing 4 over here, right? Then again we're going to check that whether this node is null or not. So no, not if this node is not null, then we're going to append this node, right? Which is going to be 4. So I'm going to append this over here. It is going to be 4. And then again we are passing preorder node dot left. Again we are passing towards this function. And this time, what is the left node of this root node, which is 4? What is the left node? We don't have any left node, right? It means we are just passing the null value, isn't it? So I'm just passing a null value. Look it over here. So again we're going to check whether this node is null. So yes, this node is null. Then we're going to return, means we are just coming back. Okay, so this function is done. Then again we're going to move towards this preorder node dot right. So what is the right node of this fourth node? That is again null, right? I'm going to pass it over here, and again null. We get the again null. We're going to check whether this node is null or not. So yes, this node is null, right? So we're just coming back again, right? It means we're done with this block of code. So we're just coming back towards here, right? Means we have already done this function. So we're going to pass a value for this recursion, right? That is preorder node dot right. So what is the right node of this 2? Okay, I'm going to rub this so that it become more clear. I'm going to rub this rest over. We don't need. Oh my god, I just rubbed that also. So we have here 4. Okay, and also I'm going to rub this. Okay, now what? So we have already done this block of code, which is this or this, and now we are coming to back towards this. That is preorder node dot right. So what is the right node of this 2? Which is 5, right? Which is 5. So we're going to pass here 5, isn't it? And then again we're going to check that whether this node is null or not. So no, it is not a null node, right? So we're going to append this node inside our result, which is going to be like this. Here we get this 5. Okay, so yeah, this is done. Now we're going to pass preorder node dot left. What is the left node of this 5, which is again null? And what is the right node of this 5, which is again null? So no need to do this further, right? So this block of code is already done. This block of code is also done, right? We have already considered the node of right or node of left of this 2. So we need to move towards this block of code. So we have already done the node left and I already append the root value. Now we're going to move towards the pre-order node dot write. Right? So what is the right node of this root node, which is 1? That is 3, right? So we're going to pass this time we're going to pass over here 3. So is 3 node is a null node? No, 3 is not a null node. So then we're going to append this inside of a result like this. And again, we're going to check the left node or left child or the right child of this third node, which is again the null node. So we're not going to consider this further, right? So this is how our recursion work, right? We're just calling this function again and again to solve this problem. So now let's move towards the coding part, and now let's submit this code. So basically the time complexity of this algorithm is big O of n because every node is visited exactly once, and also the space complexity is big O of n because recursion stack can store all nodes in worst case. So we're going to consider that also. And one more important thing that need to be remembered is in pre-order traversal, the root node is always visited first, right? So we need to be remember this. And I have a short trick for that. That is pre-order means pre means what? Parent. So parent come first, right? Then left, then right. So pre means parent. So we're going to consider the parent node first, and then we're going to move towards the left and right. So that's how we solve this problem, and that is binary tree pre-order traversal using recursion. So if you found this explanation helpful, so make sure to like this video and subscribe for more Leetcode and DSA contents. See you in the next video. Bye bye.